Right. So get just is asking, where am I now? And then set is telling it to go do something to change. And all it's doing is it's changing a pointer in the system to say, nope, I'm not in this directory, I'm over here. I mean, it's the sort of command line equivalent of being in here and then, like, you know, changing your directories, like going somewhere else. Yeah, once you set it, you're good to go. So, in that way there, everything I do in that session will be saved in that folder. All right. So, assuming that's all working, the best way to use R is just dive in. So, at a really basic level, it's a calculator. So, I mean, I can type in some math. So, here's some examples. So, like if I typed in 2 plus 2, it's going to come back and tell me 4. I know, really a lot of work for just a calculator. But the thing to notice here is that I type the commands, and as soon as I hit return, it actually executes whatever I put in there. So that could be something rather complicated. And then it gives me an answer and comes back here. And notice it's got a 1 in brackets. So like I said, everything in R is an object. So it's actually creating sort of this temporary object because I haven't saved it or assigned it to anything. So it's really saved in memory. And so that is an object of size 1. And inside that object is the value 4. So, and this will be important as we start building bigger things to store our data in. You know, other things that you would expect. So like if I did 3 plus, all of the math operators apply. So I can put in the parentheses here. So 4 times 8, higher math, 32 plus 3. So I get an answer of 35. But I could also leave off the parentheses and it would work. So how many of you guys know, please excuse my dear Aunt Sally? That's how I learned it. I think there's another idiom for that, which is parentheses, exponents. Yeah, PEMDAS. Multiplication, division, addition, subtraction. Anyway. All right. I can remember that one, but I can never remember the order of the planets. Something about pizzas. That's all I can remember about that one. All right, a couple of others. Let's see. 6 plus, if I did 8. If you do 2 asterisks, that means raise to the power of 2. SPSS uses this syntax too, and I think SAS does. It's become pretty universal. So this would be 8 squared plus 6. The other way to square an object is to use the little caret, which is over 6. So it's like shift 6. So 12 squared is 144. Let's see. There are also built-in constants. Pi is one of the built-in constants. So I can actually just type in pi. And even though it's only showing 3.141593, it's showing it to 6 digits, it's actually stored in there out to, I'd have to look it up, but it's whatever the numerical precision is for R, which is pretty significant. And you can do math with it. So 4 times pi, etc. Yes. Thank you. You're my straight man. So pi is a named constant in R. Let's see what the others are. So it turns out you can type help, and the way it's stored in here is constants with a capital C. So if I type help constants, it'll open up the help menu here. Make it a little bit bigger so you can see it. It tells me that this is it's a function built into the base software, so I haven't had to add or do anything here. And it says there's 5 built-in constants. There they are. And what's the right word? Case matters in R. So where you have capital letters and lowercase letters, those can be completely different. So that's why you see letters in there twice. So capital letters is an object of all the capital letters, all 26 capital letters, and lowercase letters is all of the lowercase letters. Is there another question? Yeah.
So in the developer area, can you develop your own constant and share it with others in the R space, or can you
Probably. Because as soon as I saw this, and I haven't researched this, so pi is in here, but what about like some of the other, like Boltzmann's constant, or I know there's others. I can't think of them off the top of my head, like E. I have a feeling those have been done. But it may be an add-on. It just may not be part of the base software. So maybe we can look at that at the end. We'll see if we can find that. But good question. I think the short answer is yes. I'm just not quite sure how to do it. All right. So if we wanted to actually see these, we could just type them in. So since they're built in, so as an example, like here's letters. And in this case, notice it's not just one. There's now 20, 21, 22, 23, 24, 25, 26. So this is actually a vector that has 26 pieces in it. And this isn't in my notes, but while we're here, I can show you this. So if I put letters and said, in brackets, say, give me the 10th letter, it's J. So this is how, and eventually, so Friday's workshop, I'm going to start getting you guys oriented on getting data into R and starting to work with your data objects and manipulating data and stuff. This becomes really important because if you wanted to say, okay, I want to go find all of the men over the age of 25, So there's ways to go in and do that so that you're making sure you're pulling out the subset that you're interested in. But under the hood, this is really what it's doing, is it's indexing everything. All right, and then lowercase letters. This is all the lowercase letters. There's month abbreviations in here. And then I think, what was the other one? Oh, month name gives you the full name. So month.name. And you'll notice with both of these that I've got a word, a period, and a word. So there's a couple of different ways to do variable names. I mean, for the most part, as long as you can't have a space. But you can have an underscore. You can use a mixture of lowercase and capital letters. You can use a mixture of letters and numbers. Follows a lot of the same rules that you would see in SAS or SPSS for naming your variables. Same kind of thing. All right. So let's actually put some data in here. So in SPSS, let's see if I can make this a little bit bigger. You'll notice that we type things and we use an arrow. So in R, you can read this as gets. It's equivalent to using an equals sign. But while this will work, you usually only use this for assigning like options. So when you're running a function and inside that function you're defining certain things, and you might say data set equals, and you have the name of the data set, and then you might say, I don't know, there's other functions like maybe you're doing a plot and it's like color equals. So those things are usually more like assigning parameters or specifications inside of a function. But if you're actually creating an object, the typical thing is to use this, what is that? Less than followed by a dash. So making a little arrow, which says take everything on the right and assign it to the thing on the left. And that's usually the convention. People will ask this, so technically I could actually write this in reverse and say, 3 times 5 and have the arrow go the other way. That will work, but that's not the convention. The convention is usually you put the object on the left and then what you're sticking in it on the right. So most of the time we write it this way. Well, this will work, so I could say, x equals 3 times 5. That'll work, but it's just not the convention. So, and trust me, if you post code out there and ask for help, somebody will make a comment. By the way, anyhow, I think sometimes developers are always looking for ways to sort of catch newbies, Oh, you're a new, I'm sure nurses have things like that too. Like if you guys were teaching me how to draw blood, there would probably be some things you would do to me, sort of, gentle hazing, to get into the thing, right? Ah, you forgot to rub alcohol first. Okay. Anyway. All right. So, the other thing you'll notice here as I've been doing this is that when I do it the first time, 3 times 5, it says, okay, it ran. I didn't get any errors, but it's like, okay, why didn't it show me the value of X? So one of the downsides to R, and this is by design, so I say downside, but it's a good thing in the long run. It doesn't just automatically come back and print out everything to the screen. Like in SAS and in SPSS, if I go and run an analysis and generate some output, it immediately gives me all of that output. So it's a good and bad thing. Depending on what you're looking at, sometimes you don't want to see all that output. And a lot of times, especially when we're first getting started, you're like, this is great. Like proc univariate tells you everything under the sun about that variable. But then you're like, well, where's the one number that I'm really interested in all of this output? So the converse side to that is that in R, sometimes you have to go pull what you really wanted. And so toward the end of this series of workshops in Workshop 4, I'm going to start introducing like doing regression, analysis of variance and stuff. And each of those create like a regression object. And then you have to do something to that regression object to pull out, the fitted equation, the p-values. So that part gets a little frustrating sometimes. Okay, so that's why it doesn't just immediately come back to the screen. All right, let's make another one. So you can create sequences of numbers. So if I wanted to say, all right, in this case, I'm doing some math and I get one value. In this case, I say, okay, let's make a sequence of numbers from 1 to 12. So now Y is an array. And I'm going to talk more about this on Friday in terms of like types of data objects. There's about 5 or 6 main ones that you'll deal with over and over. So in this case, X is a scalar. It's a single value. This would be an array of size 12. It has 12 objects in it. All right, so let's try a couple more. Another way to get a sequence of numbers is to use a function called sequence. And I'm going to type it in and then I'll bring up the help menu so you can see what these pieces mean. So it's kind of intuitive. It says generate a sequence of numbers from 0 to 10 and do it in units of 0.5. So suppose I wanted to get information on that. So help is pretty straightforward, and then you just inside the parentheses put in the name of the function. So it's like, wow, cool, she ran sequence, but what does that mean? So if I do help, it'll come back then. It has a general description, and then it'll say, okay, these are the arguments that kind of get put in there. You basically specify where you want to start from, where you want to end to, and by. So you can also give it a length. So if you give it a length, it'll do the to, from, and then divide that out and figure out what the sequence is. And then all the way down here, it'll give you lots of specific details. And then usually at the very bottom, then there's examples. So like here's one that says, give me a sequence from 0 to 1 of length 11. Here's a sequence from 1 to 9 by units of 2 by pi. Anyway. And so sometimes if you're really completely lost, just try running some of the examples at the end and eventually you can kind of figure it out. Yeah. I think so. So let's just try it. Good question. So let's just try it. Oh, why is that not working? Okay. Hopefully there we go. So yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's length 11, and yeah, it basically is figured out it's in units of 0.1. Yes?
Well, in your original code, the 0, 10, and 0.5, you didn't type in by 0.5.
I didn't because the third argument by default is by. So you can leave that off. So you're exactly right. I just didn't specify, but formally, if I brought back up here, so this is what they would call lazy coding, because I didn't explicitly write it out. So I could say from, to, and then this would be by. I get the same, whoops, not Z, sorry. I get the same answer. It's just I left off the arguments. So, but you're right, actually. So if I was to be following good coding practices and good documentation, I should do that. Some of these things, these are more sort of base level functions, so a lot of people probably wouldn't ding me on that. But if I was doing sort of higher level, more complicated functions, it's always a good idea to make sure that you have the argument and then what the value was you assigned to that argument. But yeah, good question. All right. So let's see, a couple more. All right, so now we've done this. Okay, it gets tiring to sort of look at everything on the screen, and trust me, like I was playing with the data set. I'm actually going to be teaching a course at the CDC in 3 weeks, and I was trying to find some good examples of data, so I was trying to pull one of their data sets, and when I downloaded it, it's like 1.5 gigs. I'm not going to look at that in the console. So there has to be other ways to sort of view your data. And this is much easier in RStudio, and I'll show you that here in a minute. But let's see, I don't know if there's a way, let's see, I can't remember. I almost don't use this one. So inside this R window, there are some limited menus, not a lot, but a few. In the edit window, there is this data editor. Now I have to know the name of my object. It doesn't give me a list. I have to know. So like if suppose I wanted to view Z, and I could say okay. So it's going to open it, and now I can see. So C is this list of numbers, and the way it shows it here, the little C here stands for concatenate. So it's saying this is a concatenation of this sequence of numbers. And you'll notice that after I exited out of that, what R really did was it ran this command, fix. I don't know why it's called fix, but it's called fix. Probably because you can edit it, so I could fix a typo, fix the object. Anyway, so that's what that did. Another one that you can use, there's a command called view. And I'm going to, on purpose, make it throw an error. So if I type the command view with a lowercase v, it's going to come back and say I can't find it. So it's like, well, shoot, what's the right word? What's the right thing? Just curious if it'll let me do this. Let me see. Okay. So the other way to get help is to type a question mark. If I do 2 question marks, if I type 1 question mark, then it just does the standard help window. 2 question marks says, I have no idea. I just know view should be in there somewhere. And that'll come back and give me this huge long list of everything and anything that might have view associated with it. So sometimes you have to flip through here, but it turns out the one I'm after is this one, which has a capital V, which says invoke a data viewer. And so I go, oh, okay, I obviously typed the wrong case. I've lost my window. Okay. So now if I type it with an uppercase, it works. And it just gives me, in this case, I really am just viewing it. I can't edit it here. And this will be easier to see in RStudio. So just be aware that sometimes when you get these little error messages, the error messages are not extremely helpful. But 9 times out of 10, it's usually because there's a typo somewhere. Any questions? Okay. All right, so now that we have Z, let's do something with it. So why don't I just take the sign of it, and I'm going to create something called sign Z, which is the sign function of Z. And there's lots of these built-in functions. So there's that. And now that I have both of these, I can do some plotting, which is the thing I'll show you. So now that we've generated a whole bunch of these, the other thing to do is like, I've created some of these variables, but where are they? I know they're in memory. Is there some way to list them? Turns out, yes, you can. So you can type in ls. And by the way, this is the way in like Unix. So again, a lot of the developers started in Unix. So in Unix, you don't type directory or dir, you type ls. So that's where this comes from. So if I type in ls, it's like it's going to sleep. I'm confused. Okay. Come on. No. Sorry, I hit something. I've got it. So my thing loaded. I thought I had cleared my memory, but anyway. So yours won't have this many objects. My apologies. Mine must have still had stuff in memory. But you'll see like Z is here and X, Y, and so forth. Yeah.
So those are their data name or
These are just.
the name or data?
They're objects that are in my workspace. Some of these could be data sets. Some of them are just individual little variables. Some of them are complicated objects. So it can really vary. It's almost like generating files in a way. Okay.
So on the Z file, you have the original number of the Z from 0 to 10, and then you have the same Z.
Right. So the way I've actually got these right now, there are two objects inside this big R workspace. And it turns out when we exit out of this, and you'll see this in a minute, it'll say, do you want to save your workspace? And so when it does, it'll save everything that I've created that whole time. And all of that, it kind of gets shoved into one file. So that becomes like an R data file. Because it's almost like a library. So if you think of it that way, and the library is full of books, so the books could be individual like data files, but you can have multiples of those open and then carry around the library. So that's another way to think of it.
So the list is kind of like in SAS, workspace.
Exactly.
But they all usually store all of our data, different names.
Usually, yeah, but you could I think inside I'm just not a SAS person. I don't use it enough, but I'm thinking when you're in work, like you could have multiple data files that you're pulling data from. I think you could have multiple objects in your workspace. I don't know. Anybody in here a real SAS guru person? No. It's a good question. I'm not sure. Yeah. So with it has a lot of flexibility, so it's much bigger than just thinking about one single data file, if that makes sense. All right. So now that we've got some data in here, let's just make a plot. And so you can do some pretty simple stuff just right out of the box. So like I could look at Z and plot it against the sign of Z. When it does this, it opens up another graphics window. So in that case, it's a little bit like SPSS or SAS. It opens another window for graphics. There's a whole bunch of things I could do. I can add axis labels. I could add a title and a subtitle. So I'm actually going to come in here and let's see if I can paste this over. So it let me paste it over. Sometimes cutting and pasting, you got to watch it, see whether it actually works. So I've got Z and sign Z. So one of the options that I'm defining here is X label. Oops. Make it a little bit bigger so you can see it. And then I've got little quotes. And you can use single quotes or double quotes. Most places in R, those are interchangeable. You can't mix them, but, you know, I could have double quotes here and I think it would work fine. So I put something in here. So this would be like what's on my x-axis, and then I've got a label for my y-axis, a main title, and a subtitle. So if I run all of that and then go back to my graphics window here, you can tell I've added labeling and stuff. So, and this is just simple. You'll notice too that if I'm in the console window, my menus here are a little bit different. When in the graphics window, I get file history and resize, but then there's these things like I could copy this to the clipboard, and in Windows, it wants to default to a meta file, which is actually a really good thing. Meta files that have much better resolution than bitmaps. I could print it. I can switch back to the console. If I'm in here, I can, let's see, I can't remember if I click there. I can right click and I can change, say, copy as metafile or bitmap. I can save it. There's PostScript options. I can print. All right, so that's basically the R console, the basic window. Inside here, some of the other things that you can do is I could open another script window if I wanted to have two different programs that I was playing with. Workspace is like everything that I've done to date. So when I actually go to exit, it'll say, do you want to save? I could say yes. That basically saves all of these objects. So like if I wanted to save all of these things that I've created, I could save them in my workspace. Then when I exit and come back, I can load them back in there. It just, basically saves everything that I've done in memory. If I wanted to save all the commands that I've typed, that's the history. So you can save your history and then load it back. Like if you wanted to go back and go, oh, I can't remember, did I type this or did I type that? This is like your syntax window or your SAS program. So this is like sort of saving the history. And you can also save this script. So like right now, I don't think I've saved it. Let's see. I think if I click that, it'll say, yeah, how do you want to save it? And it saves it as this R data file. Let's see. All right. And by the way, that whole change directory, set working directory, you can do it from here as well. So there's actually a menu to get to that. All right, so I'm going to go ahead and just exit out of this, and it'll say, do you want to save your workspace image? You could say yes if you wanted. For right now, I'm just going to say no. All right. And there's some more stuff, but I'm going to go ahead and, because we'll go through this again inside RStudio. So, but this is the rest of the commands. So there's a couple other things we'll do where we'll add lines and then add points on top of those lines and add color and all that kind of stuff. And then there's another little option here. The other thing I did at the bottom of each of these pages is all of that script, everything we just went through is here. All right.